This is exercise 8.6, terms of a geometric series. Geometric series, each term is formed by multiplying the term before or the preceding term by a constant. And the constant is called the common ratio. So earlier on we were looking at arithmetic series where each term is formed by adding the preceding term by a constant, and the constant was called the common difference. But now for a geometric series, each term is formed by multiplying the term before by a constant, and that constant is called a common ratio. So if we've got our geometric series term 1 plus term 2 plus term 3, etc., then the common ratio is term 2 divided by term 1, which would be equal to term 3 divided by term 2, for example, which would be term n plus 1 over the nth term, okay, just in general terms, or term n over term n minus 1, either way, okay. So we'll just look at some examples. Now just a couple of examples. Is the series 5 plus 20 plus 60 plus ... a geometric series? So, okay, let's look at term 2 divided by term 1. That's 20 divided by 5, which is 4. And then we will look at term 3 divided by term 2. So we've got term 1, term 2, term 3. So that's 60 divided by 20, which is 3. So therefore, term 2 divided by term 1 does not equal term 3 divided by term 2. Therefore, it's not a geometric series. Okay. Let's look at another example. So here is our second example, is the following: -4 plus 3 minus 2 1/4 plus ... a geometric series. Well, let's look at term 2 divided by term 1. That's 3 divided by -4, which is -3/4, I suppose, or you can just put -0.75. And let's look at term 3 divided by term 2. That's -2 1/4 divided by 3. Now you can do that on a calculator, or we can just do it using, change it to an improper fraction. We'd get -9/4. Now divide by 3 is times a third, and with cancelling you will get -3/4, which is the same as that. So therefore T2 over T1 equals T3 over T2. So therefore we have, yes, it is a geometric series. Okay, now we'll look at some other examples. Evaluate the pronumeral in this geometric series. So we've got term 1, term 2, term 3. So we know that for a geometric series, T2 over T1 equals T3 over T2. So let's just make our substitutions. T2 is x minus 4, T1 is 3, is equal to T3 over T2. That's 15 over x minus 4. Now we're going to cross multiply because we've got fraction equals fraction. So we've got x minus 4 times x minus 4, which is x minus 4 squared, is equal to 3 times 15, which is 45. So x minus 4 squared equals 45. Easiest thing to do here, what we're going to do, we can either expand, take everything over to the left, or we can just take square root of both sides. So if we take square root of both sides, x minus 4 equals plus or minus the square root of 45. And so x equals 4 plus or minus the square root of 45. Now the square root of 45 is the square root of 9 times the square root of 5, which is 4 plus or minus 3 root 5. Okay, so therefore x is equal to 4 plus or minus 3 root 5. That means that that middle term, so if we've got x minus 4, it's actually equal to 4 plus or minus 3 root 5, take away 4, that middle term. So if we look at what term 2 is, it's x minus 4, which is 4 plus or minus 3 root 5, minus 4, which is plus or minus 3 root 5. That's actually what term 2 is, okay? Okay, so that's what term 2 is, but they're just asking you to evaluate the pronumeral, which is 4 plus or minus 3 root 5. Now the nth term of a geometric series. So if we have the geometric series a plus a times r, or ar, plus a times r squared, so from going from one term to the next, we just keep multiplying by r, ar cubed. Notice that this is term 1, this is term 2, this is term 3, this is term 4, and this would be the nth term. What you notice is that term 1 has no r, term 2 has r to the power of 1, term 3 has r to the power of 2, term 4 has r to the power of 3. So if this is ar to the n minus 1, then this is term n, the nth term, okay? So always the power of here is 1 less than the number of the term. So if a plus ar squared plus ar cubed plus ... ar to the n minus 1 is a geometric series with first term a and common ratio r, then the nth term is given by t sub n equals ar to the n minus 1. Example, write an expression for the nth term of this series. 1 plus 1.02 plus 1.0404, etc. Here you'd have to be told it's a geometric series. So let's look at term 2. Divided by term 1 is 1.02 over 1, which is 1.02. Now term 3 divided by term 2 is 1.0404 divided by 1.02 equal to 1.02. So therefore the common ratio is 1.02. So here we've got that a is 1 and the common ratio is 1.02. So an expression for the nth term, so Tn equals ar to the n minus 1. So the nth term will be 1 times 1.02 to the n minus 1, which is 1.02 to the n minus 1, which is 1 times 1.02 to the power of n minus 1 will be just 1.02 to the power of n minus 1. That's the nth term. Another example, find the 10th term of this series. So here we can see that a is -1/2, r is t2 divided by t1, which is 3/10 divided by -1/2, which is 3/10 times -2 over 1, which is -3/5. So therefore the nth term is ar to the n minus 1, which is -1/2 times r, which is -3/5 to the n minus 1. That's the nth term. So we want the 10th term, so t10 is -1/2 times -3/5 to the power of 10 minus 1, which is -1/2 times -3/5 to the power of 9. So we can either, well, it's actually going to be a positive because -3/5 to the power of 9, that's an odd power, that will be negative. So the negative times the negative will be a positive. So we can write it as 3 to the power of 9 over 2 times 5 to the power of 9. That's simplified. Okay, so we know we definitely get a negative here, times the negative is positive. The 2 is just to the power of 1, the 3 is to the power of 9, and so is the 5. Okay, X form, and this is in fraction form as a numeral. For which term of this series, 3 plus 21 plus 147 plus ... is equal to 352,947. So we know that A, the first term, is 3. R is T2 divided by T1, which is 21 divided by 3, which is 7. So therefore Tn, the nth term, is AR to the n minus 1. So Tn is, A is 3, R is 7, 3 times 7 to the power of n minus 1. So if the term is 352,947 equals 3 times 7 to the power of n minus 1, we need to solve that because our term is 352,947. We're seeing what n is equal to. So dividing first by 3. So we get 352,947 divided by 3 equals 7 to the power of n minus 1. So that's 117,649 equals 7 to the power of n minus 1. So we can take logs of both sides. So ln or log to the base 10, either. I'll just take ln. So ln 117,649 equals ln 7 to the power of n minus 1. We can bring this power here to the front, n minus 1, times log 7 equals log 117,649. Therefore, n minus 1 equals log of 117,649 divided by log 7, which is, that comes out to be 6. So this ln 117,649 divided by log ln 7 is 6. So n minus 1 is 6. So therefore n is 6 plus 1, which is 7. So therefore it's the 7th term of that series is 352,947. Third term of a geometric series is 2/5, and the 5th term is 1 3/5. Find the first term and common difference. So we know that third term, T3 is 2/5, but we know that T3 equals AR to the N Tn. So we know that, I'll just write this all out again. So we know that T3 is 2/5, and we know that the 5th term, T5, is 1 3/5. And we know that Tn equals AR to the n minus 1. So therefore, if T3 is 2/5, that means that 2/5 equals AR. Now, n is 3, so it'll be 2/5 equals AR squared. We know that the 5th term is 1 3/5, so we know that 1 3/5 equals AR to the 5 minus 1. So 1 3/5, I'm going to write that as an improper fraction. That's 8 over 5 equals AR to the power of 4. So here we've got some simultaneous equations. Equation 1, 2/5 equals AR squared. And the second equation, 8 over 5 equals AR to the power of 4. So solving simultaneously, I'm going to do equation 2 divided by equation 1. So on the left we get 8/5 divided by 2/5, and on the right we've got AR4 divided by AR squared. So we're doing 8/5 divided by 2/5 equals AR4 divided by AR squared. Now 8/5 divided by 2/5 is 8/5 times 5 over 2, which happens to be 4, and the a's here cancel and we get r squared. So we get that 4 equals r squared, but just be very careful here, because r can be plus or minus the square root of 4, which is plus or minus 2. So we've actually got two values of r that could be possible here. Okay, so we've got two possible values for r, positive 2 and negative 2. So when r is 2, we're going to sub back into equation 1. We get that 2/5 equals a times 2 squared. So we get 2/5 equals a times 4, or 4a. Therefore, a is 2/5 divided by 4, which is 2/5 times a quarter, which is 1/10. So we've got therefore a equals 1/10, r equals 2, or when r is negative 2, substituting into equation 1, we get that 2/5 equals a times negative 2 squared, which actually just gives us the same answer. Negative 2 squared is 4, so equals 4a. So therefore, again, a is 1/10. So therefore, we've got that a equals 1/10, r equals negative 2. So therefore, what we've got is a equals 1/10, r equals plus or minus 2. And last example, find the value of n for which the first term of this series exceeds 200. So here we can see that a is a half, and r, the common ratio, is t2 divided by t1, which is 1 divided by a half. Or I could have done t3 divided by t2, which clearly shows us that it is 2. So 1 divided by a half is 2 anyway. So therefore, the nth term of my series is ar to the n minus 1, which is a times 2 to the power of n minus 1. So we want the first term of the series, which exceeds 200. So that means that Tn needs to be greater than 200. So in other words, all of this, a times 2 to the power of n minus 1 needs to be greater than 200. So I just need to substitute in what the a is, and we know that a is a half. So just putting that in. So we've got a half. So 1/2 times 2 to the power of n minus 1 is greater than 200. So therefore 2 to the power of n minus 1 is greater than 200 divided by a half. Now, we're dividing by a half here. So 2 to the power of n minus 1, 200 divided by a half is 200 times 2, which is 400. Now, taking logs of both sides, we've got ln 2 to the power of n minus 1 is greater than ln 400. Using your log rules, n minus 1 times ln 2 is greater than ln 400. Now, ln 2 is positive. Only numbers less than ln 1, so for example, ln of a fraction would be negative. So when I divide by ln 2, I do not need to change the inequality sign around because ln 2 is positive. So therefore n minus 1 is greater than ln 400 divided by ln 2. But ln 400 over ln 2 is 8.64, etc. So therefore n is greater than 9.64, etc. Therefore n equals 10. Now if n is 10, then we get T10 equals AR. Sorry, just lost some room here. So if n is 10, actually I'll just do it down here. T10 equals, so the value of n for which the first term of the series exceeds 200 is n is 10. We know that T10 equals AR to the 10 minus 1. A again is a half times R. Actually, we can just check our answer anyway. So let's just have a look. T10 is a half times, now R is 2, so half times 2 to the power of 10 minus 1, which is 9. So that will be a half times 2 to the power of 9, which is 256, okay? Now the term before that, because we know that the R, the ratio, common ratio is 2, the term before that, T9, would be 128, the term before that. So the value of n that gives the first term that exceeds 200 is n equals 10, okay? All right, that's it for the examples, and there'll be another exercise to follow. 8.6, please do the following. Question 1, I and J. Question 2, H, J and L. Question 3, G, I. Question 4, D, 5E, 6E, 7C. Question 10, 11, 14, 15, 17, 19 and 20.